Okay, so remember when we're counting the data, this little key right here tells us that the number on the left is the tens place and the number on the right is the ones place. So a 4/1 actually means 41. So looking at this data, this 1 and this 1, that would be an 11. This 1 and this 18 would be an 18. Sorry, 1 and an 8. So someone who doesn't prefer to use this table format, you could actually take a scratch paper on the day of the final and just start listing out the data in order in a normal format. You could list out all the data if you wanted in a normal row and work with the data that way. But see how the data is not a 1? See how the data is actually an 11 and an 18 and a 19. So when I'm going to count this, I'm actually going to just count the right-hand side. So take a minute to count just the right like I am. 1, 2, 3, 4. And I'm going to start in the back today. I'm going to start with Leslie. Leslie, once you've counted on the right only how many pieces of data, let us know how many you got. 25. Good. Everybody else get that number? So do not count the left numbers. Those are just our tens place holders. Only count the right. So we have an odd set of data. When we have an odd set of data, it means my middle is going to fall right on a number. Monday's lesson had an even set of data so you could see what happens in between. Today's is the alternate so that you're prepared for both on the test. So what is about, and by the way, I'm over to Kelton. Kelton, about what is half of 25? What's going to be the middle of 25? About 12.5, or we're thinking the thing after 12, he said the 13th. So going to count my data, Kelton, it doesn't matter which direction I start from. Go count 13 things and see if you can see where it falls on. I'm jumping to part C, by the way, for the median, because we're in that counting mode. Where's that middle? What'd you get, Kelton? Are you counting now? So if I count from the bottom, check this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is landing here. If I count from the top, I'm going to go do a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 falls there. So what number is that landing on? Circle that, but that's not really an 8. Using the key at the bottom, what actual data is that? Using this number here, Kelton, and the number at the end. 3 is like, how would I say this number? So for example, Kelton, this number is a 40, 41, 42. So 38 is your number. Does that make sense how that key works now? That this is just saving. Why would they present data like this in this weird stem and leaf plot? It's to save us writing time. It's to save us having to write all the data out in order. Great, I can just work off this table. So my median is 38. That's also known as my Q2. Now the one that takes us the most time, if we happen to get asked this question, is the mean. Now you're going to use your Desmos or your phone calculators right now, and you're going to take a second and you're going to go and add up all this data. So what am I actually typing into my calculator? I'm going to type in 11 plus 18 plus 19 plus 19 plus 20 plus 20. Do you see how I'm using that data? So go. Add it all up. We're going to see what number you guys get before we divide by 25 for the mean. And by the way, I'm at Miguel now. Miguel, when you think you have the number so that we can compare and see if we all added correctly, go ahead and tell us what you got. Good. Can someone else confirm they also got 998 when they added it all up? Yes? Okay, good. Those of you still going? Now, did anyone not get 998? Are they not reading the key correctly? Are they not realizing that this is a 61 plus 62 plus 62, etc.? Make sure you're using that key. So when you divide 998 by 25, what do you get, Miguel? I don't remember that number from yesterday. Can someone else confirm? Is that it? Okay, it means I remembered it wrong. And did that have to be rounded? Like, is this an approximation? Okay, so make sure you've got that approximation symbol there. So the mean can be a decimal. And if this is a type in the blank box on the final, you're going to want to make sure you're rounding correctly. If this is a choose your answer, multiple choice, you're going to look for your 39.92. Is everybody okay with adding all that data and dividing by that number? So this is another way to present data, but it's also helping you practice for mean, median, mode, and all the other questions we might ask you on this final as well. Okay, let's go to the mode. Notice there's a little hint here. Place in descending order separated by commas. So it's like, wait a second, can there be more than one mode? Why, yes, there can. So I'm over at you, Roberto. And this time, Roberto, looking at things that are occurring more than once. Mode means most. What numbers are you noticing that are occurring more than once? Like looking in the top row. 19 happens more than once. So it's, by the way, it's saying descending order. That could have been what you were pausing for. Let's go down to the bottom of the list first. When it says descending order, it means the biggest numbers first and then going down, right? So looking in the bottom row, are there any things that occur more than once? So we're going to start with the 62. And then looking in the next row, anything we can add? Good. Next row, I don't see any repeats. How about the third row? Okay. Uh-huh. Good. Good. So sometimes you'll see data where there's two modes. That's called bimodal data. And sometimes you'll see data like this where there's several things that are occurring twice. It's called multimodal. And so that you do realize, in case you're taking an SAT, an ASVAB test, or a future test in your statistics at MiraCosta, can there be more than one mode? Why, yes, there can. Okay. So we listed it out in descending order because it told us to. If it said to list it in ascending order, we would go from smallest to biggest. Good? All right. Find the range. I'm over to Carla. Carla, we're going to write down first what range is in case we're on the day of the test and need to know. Range is our biggest piece of data, our max, minus our smallest piece of data. Can you tell us what our biggest piece of data is, Carla? Good, 62 it is. And then our smallest piece of data. Good. Go ahead and subtract that for us and tell us what you get for the range. Good. So there's two kinds of ranges now that we've talked about. We've talked about this full range, like regular range, our biggest minus our smallest. And then we've also talked about the interquartile range, which we'll get to below. So be careful with what word they're asking for. There are two different kinds. Okay, the four quartiles, and by the way, it's a Q1, Q2, Q3. So I'm only going to be asking you one or two questions about this on a final, right? So look at all these choices I could come from, but it's only going to be one thing. What if I give you a stem and leaf and say, what's the mode? That's all I might be asking you about that picture. What if I give you the stem and leaf plot and I ask you for the Q1, Q2, Q3? So you're going to only have to answer one of these questions. Just keep that in mind. Okay, so I'm at my Q1, Q2, Q3, and I'm over to Blanca. And Blanca, we already got the Q2 above. Let's put that in. That was our median, our 38. Okay, now the Q1 is the first half it's the middle of the first half, and our Q3 is the middle of the back half. So let's put that down. So if I go up and I'm thinking about looking at 12 things, what's the middle of 12 more or less, Blanca? 6. So the sixth thing, but if I count 12, my 12 things, if I count 6 things this way and 6 things this way, it's an even first half. It's going to have to fall in between two numbers. So let's go look at our data, starting from the first one. If I go 1, 2, 3, 4, 5, 6, counting from the front, or I go 1, 2, 3, 4, 5, 6, counting from the back, it falls in between two numbers. What does it fall in between? 20 and 23. And if you picture on a number line when it's odd like that, like what is the middle of that? I want you guys to realize there's a way to find a middle, and that's called taking the average of those two things. So you're going to add those together for us, divide by 2, and find us the middle, and it's okay to get a decimal. You got it. Okay, so my Q1, did you say 23.5 or 21.5? Oh, good. I didn't make it up. So 21.5 it is. I want everyone to do the Q3 now. Go see if you can do the Q3 before Blanca tells us what she gets. Remember, it's an even back half. It's 12 things. You got to find the middle of some 2 things. All right. Blanca, what'd you get this time? Did we have to do an average, or was it a little bit more straightforward?
Well, we have to do an average because it's between 58 and 59. So then what I got was 58.5.
So hang on real quick. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm getting that it's between 56 and 58. Will you count one more time for you and double check that for me? Is that right? Okay, perfect. And like my little slashes are covering some digits up too, so I have to be careful with that. Okay, so in between 56 and 57, hi, what would that be? Sorry, in between 50, I gave you the answer. In between 56 and 58, what was that going to be? I hate when I do that. I do that all the time. All right, you guys. So 57 is our Q3. Are you here just to watch, or you want to say hi to everybody for a minute? Okay, good.
Thank you.
Thank you. All right, so in between those two, does everybody see that 57? So sometimes we have to take an average. It's odd. It's like I can't visualize it. Sometimes it's nice. It's right in between a 56, right in between a 58. It's right on that 57 line. All right, I'm down to letter G, and I'm over to Daisy. Daisy, what percent of the teachers travel more than 38 miles to work? So this key here, more than. So everybody go back up to that data. And you're thinking to yourself, how am I like working in this data, in this format? Am I going to want to list this out on the day of the final, or am I going to be okay working with it in the stem and leaf plot format? And it's weird to me because this question says 38 miles to work. It's exactly how many miles I drive to work. It's like they wrote this for me. Okay, so 38 miles. Do you guys see that key, how the one that Kelton gave us right at the beginning was that 38? And it says more than 38. So what do you think, Daisy? Do I count the 38 or do I count everything what? Say it again. Everything but the 38, but do I count before 38? For more than 38, we're going to count everything after 38 for more than. So go ahead and start counting those datas after that 38. And tell me how many you get, Daisy, and then we'll confirm it's what we got. That's 12 out of how many? Good. Go ahead and divide that to get us a decimal, and then we'll convert it to a percent. Good. And then what percent would that be? Great. So 48% of the people at work travel that much. Okay, here's that interquartile range that I was talking about. This is the other type of range, the IQR, that is our Q3 minus our Q1. And we have both those numbers from above. I'm over to Adrian. Adrian, take a minute to finish writing letter G. And then what's my Q3, Adrian? And what's my Q1? And just so that we're clear, where did I get that from? I got that from right here, from my calculations earlier. And I got that from right here, from my calculations earlier. Okay, can you go ahead and subtract those for us and let us know what you get?
I got 35.5.
Good. And that's my IQR. Okay, so looking back across that, which ones are we going to be okay with when I give this to you on the final, or are we feeling okay on all of them? You know, remember it's open notes.